So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 327, and in this video we continue with our exercise, and we stopped here about number 28 and now we are on 29, which is a function call or an overloaded operator expression whose return type is R-value reference to objects such as std_move. So the question is value category, and then make a code example. And again, like all time, pause the video and try to answer first on your own and then compare it with my answer, or even better with online resources, and then we continue to the next. Okay, so pause the video, and of course, like all time, I'm not pausing, I just jump to my answer. So the 29 we have, this is the code example, but first let's go here. A value category is an X value, and you can see this here, this std_move. When you see something like that, you should automatically think about X value, because this one is all time casting an object from which is an L value. For example, this X could be an L value, and this move is all time making casting it to an R value reference, and this cast here itself is then an X value. All right, X value and a code section. Let's go here. So watch a code example. So 29 here, I have a class. This class, I have a function, sorry, and this function has a return type of an R value. We can see this with this double ampersand, and this function is taking just a reference, again a const reference, to my class which I have built here. This, you can see, it's just a struct, my class. This class has an int value and it has even a constructor, and it is just assigning a value which we give in to here, to this one. All right, and let's see what the function itself is doing. This function itself is creating a temporary class, my class, and it's taking the reference value which we give here in and assigning it to this local my class temp. And here in the return value, you can see I'm using std_move, and when you see std_move is casting what we have here to an R value, so this one here, and this cast itself is an X value, and with other words, we are returning here an X value. And when I go here down, here is again the whole example. I start with my class, I create here an a variable up, and then I with an argument 10, and then it will return here. I called first of all this class, what the function what I showed you before, that was our X value, and this X value is returning a R value reference, and then I'm assigning it just to this R value reference which I have created here. So it is just creating references more or less and assigning them to each other. But important here is this when you see this one here, this one is all time the X value cast, and we will see this in a moment why I say cast to it, because it says here move, but in real this one is nothing else as a R value cast. We'll see. I showed you this already in another video, I think, but yeah, we will see it here in a moment again. All right, with that said, let's jump to the next question, which is here, the number 13, and it says here an array we have here, the built-in subscript expression, this one here, and the whole thing is an array in where one operand is an array R value. Okay, this is just a code text snippet which I copied out, and you should now say value category of this one here. In this case, and then make again a code example, and right now you can pause the video, try it on your own, and like all time I jump to the answer now. After you finished your try, start the video again, and we go here to number 13. First of all, value category is an X value, and here important is how this x value comes is created, it's not easy to see, a little bit complicated, because when you say this one, we have here an array, let's call it a, and then we have any number here, 2 or something. When you write something like that, let me write this, for example, a 2 3 or something, this here, and so this part here would be not an this part here would be an L value. Why is this here an L value? Because normally you can assign to this value anything, right? We know when you can assign to something and it has a name, then it's almost all time L value. But now it's the question, when it's this an X value. Let's jump here to the code section again, and here I have now made on 30. It was 30, I think. Okay, where's my example? Here is my example. Okay, so here is number 30. In this example I am using here, I just copied this from ChatGPT, I think, and ChatGPT has used here a vector, and we have not talked about vector, I think, in detail, but it's the same as, almost the same as an array. The only difference is we can define here a type, and this type is all time written in this square, this brackets here, this arrow brackets, or what is called. And then you can just define here, like an array, the values if you want. And yeah, you can see here is this vector defined, and then what's done here again, here is std move, and again, like before I said, when you see this is all time trying to casting an object, an existing object, most time an L value, directly to an R value. And here house number 2, for example, this is house number is the vector name, 2 is just the index, actually. This is not the value 2 here, this is the index 2, which is this one here. So house number 2, the third value, would be value 3, will be converted. So this one is an L value, but now I use this move, this whole expression becomes an X value, which means I have a return type of this R value, and then this X value I can bind, for example, here to an to an R value, because now it's no more, for example, an L value. When I just take this one here, that would be an L value, but I convert this one to an X value here. And yeah, that was the example from ChatGPT. I'm not sure we can see this here in detail, but the most important part is that you know that this one, when you see this one, it is all time creating at least this part as an X value expression, because it's creating all time an R value reference, this kind, and it's almost all time an X value. And this one is just an assignment. All right, and yeah, let's go here a little bit further, I think, and we go to number, let's go to 30, not here, to 31, and let's see this one here. It says here, cast expression to R value reference to object type such as static, cast, char, this one here. So I hope you already know this one here. Should be I think we talked already about this one, but again, value category and make a code example. Pause the video and try to answer this as good as you can. Should be fairly easy now. And I jumped here directly again to the answer. First of all is the X value, and this one here, let's see, not here, and this one here is an X value, yes, but this one here is actually what? It's exactly this std move. They are almost equivalent, because this is just another syntax actually, and because they are doing the same thing. So this std move here is doing exactly that, what you see here with the static cast X. This one is a little bit more visible, I think, because you see exactly what here is doing. You can see here we are casting to a char which is an R value, right? With double ampersand. Okay, it's an R value reference, and here this value X, and this move is a function call, and you have to know that this std move is exactly doing this here, std cast char, like this one here. And yeah, and then make a code example. Let's watch this one as well. And here that was 31, I think. And then you can see we have here, I have here two functions, no return type. Again, the standard parameter, you see the const char, but this time interesting is here R value reference, and here we have just this normal with 1 ampersand reference. It's most time for L values. So, and here's the question, which one is most time called? Can be confusing sometimes, but I think we talked also about this one. Let's go here to number 31 first to see the example which I have. You can see here we call now, okay, first of all we have here, we create here a variable X. It is a char, we assign it a value, a character. Yes, I assign it the capital letter A, okay, and then I call here the function, and here you can see I use now the static cast. Here you could also use std move, right, and then write X, then you don't have to write this one, but like I said before, it's really the same thing. And this one here is an X value, it converts the L value, this one X, here we have a name, this is this one, this X here is an L value, but the static cast here with the X in it becomes an L value expression, and then we are just calling the function here which I showed you before. But the question is now, wait a minute, which one is here called? We have here one with this 1 ampersand and one with the second 2 ampersands, and remember all the time the compiler will prefer when he has an X value, he will all the time prefer the double ampersand. Why? Because of optimization, because the compiler can optimize behind the scene with a double ampersand, which is an X value better, because then it can use move semantics and move assignment, all these kinds, which means in the end the compiler can avoid copying behind the scene. So, and that's a very big plus, which we will also utilize as a programmer. When you have big data, you try to get something X value, you will prefer an X value over an L value all time. And keep this in mind. So if the compiler has here 2 options, it will try to bind all time to this one. But if the compiler has no option or the requirements are not there, it can also bind to this one. That's why both are possible, but this one is the better version. All right, and yeah, that was 31. And you can see here, here I think I have made here another example. Again, the same call, the function, but this time I use std move, and like I said before, this std move and static cast are almost identical, just a little bit different, because here I have to call this function move, and here I make it directly. So yeah, with that. All right, and let's see if we can go even further here a little bit. And it says here static cast. Let's see what we have here. I think that's okay for this video, because the other 2 we have to talk a little bit more in detail again. All right, if you have any questions like all time, write in the comment section. See you in the next video. Bye, good luck, and like all time, have fun and never give up.